Hi everyone, I'm back in Santa Monica. Hello. It feels so good to be at home, okay? Let me use this video to show you what you need to do for week 7. We are going to start a new module which is about atmosphere, humidity, and stability. You finally will understand the cloud formation, and starting from next week actually, or week 9, sorry, next module, we are going to identify our cloud. Okay, all right, so let me share the screen with you. Okay, so let's first go to our module number 4, understand air humidity and stability. Okay, so first, you know the drill, how you need to go through the study guide, which I provide study questions, okay, and you need to be able to answer all the study questions and to prepare for your quiz, okay. And same thing, we will have the videos to help you understand and answer those study questions, okay. So this is the first one, very important page. Let me go back. So the second one is my lecture presentation. So in a minute, I will start presenting the lecture, and then to show you what you need to focus on each slide. Okay, and for this week's discussion, same thing. Okay, you first need to summarize, but only the first 2 bullet points in my lecture presentation, and make sure you in your summary to answer all the questions here. But okay, don't worry, you can find all the answers in chapter 4 and lecture presentation. Okay, so I want you to read your chapter and my lecture presentation carefully. Okay, all right, and then don't forget to ask at least one questions, okay, in your when you study, okay, and then reply to your peers, same thing. Okay, all right. So, and weather log, same drill. Okay, same drill. You need to summarize the weather conditions for the date, 12th, starting from Monday, and then to Sunday. Okay, and here you still don't need to fill out the cloud type column. We'll do that from the next module. Okay, from November. Okay. All right, so next I want to give you this short presentation on atmosphere humidity. Okay, as you can see here, let me go back for your summary. This week our focus actually is just here, this one. Okay. This one is the humidity. So you can see we are going to understand what atmosphere humidity is, okay, and how the phase change in hydrologic cycle associated with it, okay, and then focus on evaporation and condensation. Okay, so the chapter you are going to read is chapter 4. Okay, so in your textbook, okay. So this is our outline. Summarize those 2 in your summary, okay, and then let me present it. Okay, so this slide basically introduces you different phases or different states of water, and why they're how they're different. You have a question on that, how they're different, and what is latent heat. On page 96, you have a very detailed explanation on that. Okay, but let me explain it. So here is the water molecule. You have this molecular structure. Okay, you have this oxygen atom. This is a hydrogen atom. Okay, you will have oxygen atom carry negative charge, but hydrogen atom carry positive charge. Okay, so here different phases, actually they're very simple. In solid phase, because you have negative here associated with oxygen atom, and you have positive charge associated with hydrogen atom, we call that hydrogen bond. And this hydrogen bond in this solid phase will be very tight. okay, they will form this hexagon structure over here. Okay, that's your solid phase. So let's take a look at it, this liquid phase. In this liquid phase, this bond is not as strong as this one. So you can see those water molecules, they fall apart. Okay, so the question is, how can you change the solid ice to liquid water? Melt it, right? And you need energy. You need to turn on your stovetop or put your ice cube in a warmer place, right? So the energy is used to break this hydrogen bond. So that's why melting, you need energy. And this energy is called latent heat. Latent heat. Okay, let me annotate. Can I annotate here? I cannot annotate latent heat right here. Okay, and go back. You collapse, right? The molecules collapse, freezing. You actually release latent heat. Same thing as vaporization and condensation. You can see here, if you change from liquid phase to gas phase, water vapor, right? This hydrogen bond become even weaker, so you need extra energy to break this bond apart. So vaporization or evaporation need energy. Think about when you finish swimming, you get out of the pool, you feel cold, right? That is evaporation, take away the energy from your body. Okay, and condensation actually release energy. You know, cloud is formed through condensation. Actually, there's a tremendous amount of latent energy released when you see cloud formation in the atmosphere. It's amazing. Okay, all right, so that is a phase change and latent heat. Okay, and related to the dynamic status movement of our water in atmosphere. Okay. All right, so the next question is how much water in atmosphere? Okay, actually very little amount. So you can see if you treat the entire the globe, the water as this bar, okay, ocean take the most part. Okay, ocean have the highest percentage, and our air is not here, but our air is fresh water. The water in the atmosphere is fresh water. Then let's break that down. Okay, into this column. So you can see still the atmosphere is not large enough to be shown on this column, right? It's still in this very little 1.2 fresh water. Okay, then let's continue break this very small amount down into this. Then our atmosphere is here. Okay, all sounds very abstract. Here, NASA have this very good poster to show you visually. Okay, so you can see if you treat the world's entire water globe water into this into a ball, okay, condense that into a ball, is this part. Okay, but our atmosphere is like this compared to the entire size of our Earth. You can see very little amount. Okay, all the Earth's water is in a bubble, and the atmosphere water even smaller. Okay, like a droplet. Okay, here you have where you can find the water, where the water exists. Okay, and then where is the air? Here, atmosphere. You can see very little amount. Okay, so that is a stat. That is how much in water phases. Actually, all the three phases, and they constantly change. That's why our atmosphere have a huge influence in our temperature. Okay, and also other Earth systems. Okay, and then the next concept in this chapter is this water in atmosphere and how that related to the hydrologic cycle. You learn hydrologic cycle, right? You learn hydrologic cycle in high school. Actually, the official name or immediate name is called hydrologic cycle. Okay, and basically they address in atmosphere where they from, where the water from, and where they go. Okay, so you can see if imagine you have a water droplet in the ocean, okay, through evaporation those water will become the atmosphere water, right? And then through condensation, that will become cloud and liquid droplet in the cloud. And wind will blow those clouds to the land, or evaporation from the land can also form the cloud, right? And then when those clouds, the droplet become too heavy, you will see precipitation. Okay, precipitation will send the water to the ground, maybe go to the snow cap in our Sierra Nevada mountains, right? Or go to the soil, go to the surface, or go to our running water, right? And those surface water actually can be soaked into your soil. We call that infiltration or percolation to groundwater. That is water underground, okay? And the water in the soil can be sucked, can be absorbed by our plants, and through our plant leaves, you also have this evapotranspiration, send the water back to atmosphere, right? And well, because they are all driven by gravity, right? And then all the surface water and groundwater, they will eventually back to ocean, and this water cycle, this hydrologic cycle, back again. Okay, so you can see here the exchange, the flow, those evaporation, precipitation, they are very important. They're very important. They send the water from one reservoir, okay, the place water can temporarily stay, to another reservoir, right? Okay, and if you see the phase change, for example, from liquid in the ocean to gas in atmosphere, you will have that latent heat related. Okay, so that actually also sends the energy to atmosphere from our ocean, right? Okay, so I want you to watch this video to learn more details about this evaporation and this hydrologic cycle, and pay attention to the energy exchange in each process, okay, in each exchange, okay? All right, eventually in atmosphere, moisture in the atmosphere, we want to know the main inputs and the main outputs using the concept of hydrologic cycle. Okay, main inputs actually include two parts: evaporation, okay, that is the water from our water surface or ground, or evapotranspiration, that is the water from our plants. Okay, and main outputs will be condensation and precipitation. The difference between precipitation and condensation is condensation, that is gas to liquid, right? That's a phase change, and the phenomenons you will see, that is cloud, fog, and dews, the water droplets on the leaves, right? But precipitation is basically the water droplet in the air is too heavy. Okay, they are going to falling down to the ground. Okay, falling down to the ground. So that is the difference. And when the water in atmosphere, we are also going to measure that. Okay, you have two ways to measure it. One is how much, the specific amount, the absolute amount. You will have specific humidity, mixing ratio, and water pressure, vapor pressure. Read your textbook to learn how you define each, okay? And how saturated air is, how saturated the air is with water vapor is another way to measure it, okay? So here, every day you learn from the Weather Channel the relative humidity, right? Actually, relative humidity doesn't measure how much, it measures how saturated, how full the air is with water vapor, okay? So for example, let me give you this example, this illustration, to explain what's the difference between those two. You can see in those two beakers, okay, you have the same amount, absolute amount of water in it. Okay, but if I ask you how full each bucket is, how full each beaker is, you probably will say, oh, this one is halfway full, this one is 1/3 full, probably, right? So you can see the same amount of water in the jars. It's make the relative humidity, how saturated the air is with water vapor, they're different, right? So the that is basically based on the capacity, the ability for our air to hold the water, right? Okay, so you can see this jar have more capacity, so the same amount won't make this jar full, even halfway full, but the same amount will make this smaller jar full, right? Okay, so then let's focus on evaporation and condensation. And you need to know the conditions for evaporation and conditions for condensation. Okay, of course, evaporation, you need energy, and also the air above it cannot be saturated, cannot, full of water, okay? And conditions for condensation is the air must be saturated and they don't have any room to hold more water vapor, then you will see actual water condense out. In addition to that, you also need this condensation nuclei, okay? And our water can grab on, can form the solid phase. So page 94 give you more explanation and also this video, okay? All right, and then how to measure it. This is some calculation, okay? To measure how much, you can use this so-called specific humidity, the mass of water vapor, divided by the mass of air, okay? Mixing ratio is the mass of water vapor divided by the mass of dry air, containing water vapor. So what's the difference? Actually, it's not very big difference, okay? So let me show you the equation you see here. Okay, you see here, you will see the difference. Okay, and the water pressure is the pressure exerted by water vapor molecules in the air. So air is a mixture of different gases, right? The water vapor is one of them, and air can give you the pressure. You learned that from module 3, right? And the vapor pressure is just the shared pressure from water vapor, and this water vapor is directly influenced our boiling point. So this video have an explanation. Okay. All right, and then the saturation basically is maximum our air can hold how much water. Okay, the maximum amount that directly related to temperature. Okay, so you can see here, you can use this chart actually to look it up. It's a fixed relationship. Okay, so for example, in 0 degrees Celsius or 32 Fahrenheit, approximately that is 4 grams. But when you increase your temperature, you can hold more, actually a lot more, right? Okay, so hot air can hold more water. Okay, then we can measure the percentage of saturation to use this relative humidity, right? So the relative humidity is the actual amount of water vapor now in your air divided by the capacity, saturation water vapor. So for example, your capacity is this large, this bubble, solid black circle, but your water vapor is this amount, then you use this amount divided by this big circle, that is your relative humidity. Okay, but here we have multiple ways to measure actual water vapor and saturation water vapor. Okay, so here actual water vapor can be measured use what? Specific humidity, mixing ratio, and water pressure. Okay, and saturation maximum, you can use the chart to look it up, and times 100%. That is the relative humidity, how full you are. Okay, and to make the air saturated here, actually there are 2 ways based on the equation you will see. So number 1 is you keep the temperature right, keep the temperature fixed, and add more water. And this ratio will eventually become 1, right? Okay, that is one way, add more water vapor. Basically, you encourage evaporation. You can make the air saturated. Another way actually is to decrease the air temperature, because this saturation water vapor is directly related to temperature. Cool air will hold less water, right? Think about you put this one actual water vapor fixed, but you shrink your saturation, your capacity, then you can also make the air fall, like the chart this one shows you, right? So that actually is a very important process for cloud to form. Cloud form up there in the sky, right? When you go up in troposphere, temperature decreases, right? Our air will become cooler, can hold less water, so that's why you can only see cloud at certain level, right? So that is when air become 100% full, you see condensation happen. Okay, so here's the experiment to make a cloud in a jar, and then here to look at this video to see how you can decrease the temperature to make the air saturated. Okay, and the dew point temperature is exactly the temperature you can make the air saturated. Okay, it's at the temperature. This one, dew point temperature, actually is quite complicated, okay, and it's all dynamic. It's related to the air temperature, air pressure, and basically the location where you are. Okay, so dew point temperature will be also given in this class in all the assignment and quizzes, but you need to understand what is dew point temperature. Okay, all right, last but not least, how to measure it. You have multiple instruments. This hair hygrometer, basically using the human hair. Someone say I have a bad hair day, right? When the hair is dry, well, very crispy, right, and can be messy, right? We'll change the length, and the length of the hair length will change. Okay, but this one we don't usually use it in the field when we out there do our field work. We use this one, sling spectrometer. So I want you to understand this one. Okay, read your textbook. Here also you have a video to explain it. Okay, basically you have two thermometers. You have one with the wet cotton cloth, that is a wet bulb. Okay, and then this one is naked. Okay, this is the normal thermometer, is the dry bulb. Then you are going to spin it, okay, and you will see temperature difference, the reading difference from those two thermometers. And because this wet and cloth, you have more evaporation, okay, this temperature will be less. So based on the difference of those two thermometers, you are going to you can look it up with the relative humidity. Okay, and I want you to understand, make sense of these. If the surrounding air is drier, then you will have more evaporation from this cotton cloth, right? And then the wet bulb temperature will be even lower, so you will see a huge difference, right? If the surrounding air is saturated with water vapor, you won't have much evaporation from here. So you will have, relatively higher temperature in this wet bulb, and then that will be very close to this dry bulb, so smaller difference between those two thermometers. Okay, so make sense of that using this video. Okay, all right, so that is actually all the concepts you're going to go through this week, and it is covered by week 4. Okay, by chapter 4. Okay, chapter 4 is not that hard. I hope you can read through it and to find the answers to those questions. Okay, and then give a very good summary on your discussion board and contribute to our learning community. Okay, so that's it. On Monday, tomorrow, I will hold my office hours at 6. So if you have any questions, please come by. Okay, bye.